Hi students, welcome back. In today's video, we are going to solve some problems that involve the real-life applications of graphs. Alright, let's start off by looking at this distance time graph of a car. The x-axis here measure the time, right? And then the y-axis measure the distance traveled in kilometer by the car. Alright, so the car will start from rest. Okay, when time equals to 0, of course the distance traveled will be 0. And if you see this part of the graph, the car is actually traveling a constant speed, right, up to 60 kilometer, and then you see that it stay at 60 kilometer for a certain period of time, right? So that period of time, it's what we're interested in. Okay, this portion here, it's the part where the car, right, it's not moving, right? So if you were to draw two vertical lines that touches your in this case there is not the x-axis but rather the time axis, right? We can see that the time difference, right, the time difference is actually 2.5 minus 1.5, and that gives you 1 hour. So in other words, the car is not moving during this 1 hour period of time. Alright, so that is part 1. And so for part 2, right, find the average speed of the car in the first 2 hours of the journey. Alright, average speed for the first 2 hours of the journey. Right, so average speed, it's actually can be found by the formula, which is total distance traveled right in the first 2 hours over the time taken. So for the 2 hours, we can see that the total distance traveled is just 60 kilometer. Okay, you can see that the car actually start from rest, go all the way, travel for 60 kilometer, and between 1.5 to the 2 hours, this part here is stationary. It's not, there's no increase in the distance traveled. So therefore, the total distance traveled for the first 2 hours is just 60 kilometer. It's just 60 kilometer here. So therefore, you just take 60, divide by 2, and that will give you 30 kilometer per hour. All right, let's look at part 3. Find the average speed of the car for the whole journey. Right, so to find the average speed, then we have to find the total distance traveled. Okay, divide by the total times taken. So the average speed for the whole journey, all right, let's calculate the total distance traveled. So for the first 1.5 hours, the total distance traveled is 60. Right, so that will be 60, and then it never moved, stationary, so there's no increase in the distance traveled. And after that, it start to travel again at the constant speed all the way up to 120. So in other words, the total distance traveled is 120, right? 120. So divide by the total time, the whole journey actually takes up 3.5 hours. Okay, from here, if you were to draw a vertical line, you can see this is you will touch here at 3.5 hours. Alright, then you can just easily use a calculator to help you evaluate the answer. And that it's 34.8. Okay, to express the number to three significant figures, so there will be 34.3 kilometer per hour. Alright. Okay, the last part of the questions involves sketching the speed time graph of the car for the whole journey. So we'll do it at the next slide. Alright, so to sketch the speed time graph of the car for the whole journey, we would have to find the speed at the different timings. So right now what happened is there are three different timings. We need to find the speed for the first 1.5 hours, this portion here. Then of course for the next 1 hour, the speed is 0 because the car is not moving. There's no increase in any distance traveled, so it's not moving, so it's stationary. Therefore the speed is 0. And then for the last 1 hour, it's moving at a constant speed, right? So we know that speed is just a change in the distance over change in time. Basically, speed is just to find the speed for the first 1.5 hours is basically just finding the gradient of this line here, the one that I circulate for you, the gradient of that blue line. Okay, so for the first 1.5 hours, the speed is change in distance over change in time, which is just this portion here, which is basically just 60 divided by 1.5. Change in the distance over change in the time. Okay, so it's just 1.5 for the time, 60 for the distance. So 60 divided by 1.5 will be 40 kilometer per hour. So it means that the car is actually traveling at the constant speed of 40 kilometer per hour for the first 1.5 hours. Then for the next 1 hour is stationary, so the speed is equals to 0. And for the last 1 hour, all right, this is the one that we are interested in finding. So from here to here, the change in the distance will be 120 minus 60, which is just 60. Then the change in time will be 3.5 minus away 2.5 gives you 1. Right. So it will be just 60 divided by 1. So it's traveling at the constant speed of 60 km per hour for the last 1 hour. So with this information, we can actually sketch the speed time graph. So let's start off by drawing your axis. Okay, so the axis is time per hour. All right, you can start from 0 to 0 hours, 0.5 hours, 1 hour, 1.5, 2, 2.5, 3, 3.5. And there's only two speed that we are interested in. Three speeds, sorry. One is 0 kilometer, one is 40, one is 60. Okay, so for the first 1.5 hours, the speed is 40 kilometer per hour. And then for the next 1 hour, it's 0. Vehicle is not moving at all. Then for the last 1 hour, the speed is 60 kilometer per hour. So this is how you sketch the speed time graph for the whole journey for the car. Right, so now let's look at another question that involving speed. Let's look at another question where the graph shows the speed time graph of a car. All right, so you asked to find the acceleration of the car in the first 2 seconds. So the acceleration is basically just the gradient of this line here. Acceleration is just change okay, it's just change in your speed over change in your time. So it's basically just the gradient of this line here. All right, so the change in the speed will be just 10 minus 0 over the change of the time will be just 2 minus 0. And that gives you 10 divided by 2, which is 5 meter per second squared. Okay, right, the units for speed, it's meter per second, and if you're going to divide it with another second, so meter per second is m over s, so divide by s, then change your division sign to multiplication, flip the fraction, so you have m over s times s squared. That's the reason why the units for acceleration is meter per second squared. Okay, so that's first part, which is relatively easy. Then second part, you are asked to, or you're told, told that asked to find the average speed. So to find the average speed, we need to find the total distance. So here, the questions actually guided you to find the total distance. It says that the distance traveled is basically just the area under the speed time graph. So what do you mean by area? So area means we need to find the pictures that we got. The speed time graph actually represent a trapezium. Alright, so when you say area under the speed time graph means we're finding the area of that trapezium. Okay, so if you were to recall the formula to find area of the trapezium, right, you have a half first times sum of the parallel sides times the vertical height. Okay, wait, let me write it properly. Alright, so which the parallel sides? The parallel sides refer to this guy here. Wait, I think I will have to erase this first. Refer to this one here, which is 5 units, okay, minus away 2 units, and the other side is here 6 minus 0, and then your vertical height will be just 10 minus 0, gives you 10. So 5 minus 2 is 3, 6 minus 0 is 6. Alright, so this will just be half times 3 plus 6 times 10, and that will gives you sorry, my mind is not working, I need to use calculator. 3 plus 6 is 9, 9 times 5, 45. Okay, right, so that will be the total distance traveled, and so therefore the average speed would just be 45 divided by the total time taken, which is 6. Okay, the total time taken here is 6 seconds, so 45 divided by 6 will give you 7.5 meter per second. Make sure you write down the correct units. Right, let's do another question that involved also a speed time graph, again of a car, right? And for part 1, we are asked to state what does the gradient of OA represent. Okay, so basically the gradient of OA right is by taking the change in your speed, right? This portion here over change in time here. So what we're actually finding is the gradient of OA is just the acceleration. Okay, so the gradient of OA is equals to the acceleration of the car in the first 30 seconds. Okay, that's it. Right. All right, let's look at part 2. So you asked to find the speed of the car when t is 15. Okay, t is 15. So t is 15, probably it's when t is 15. Okay, 15 here. Right, so if we draw a vertical line, what we are finding is this speed here, which we do not know. So I'm going to just let it be v meter per second. Okay. Now, so if you understand the meaning of that, the gradient of the OA is the accelerations of the car in the first 30 seconds, right? If you understand that the acceleration is finding the gradients of OA, and we are talking about a straight line. So the gradient at any 2 points, on the straight line will gives you the same gradient. Right. So in other words, if I'm going to indicate this point here, where the it's indicate the x coordinate is 15, because we are asked to find when t is 15, right? The y coordinate we do not know, let it be b. And then there's another point here, which we can let it be x coordinate is 30, y coordinate is 14. And another point here, let's call it that's origin. So x coordinate 0, y coordinate 0. So that means the gradient of your point, okay, we're going to call this point x. So the gradient of ax will be the same as gradient of xo, right? Because we're talking about the same line. So any line segment joining 2 points will have the same gradient, right? Okay, so how do we find gradient of ax? So gradient of ax will just be y2 minus y1 over x2 minus x1, would just be 14, which is a y2 minus b over 30 minus 15. Okay, and then the gradient of x, okay, we're going to call the origin O, the point O. Okay, let me write it properly. This is x. We call this point, we shall call this point x. So the gradient of xo will again be y2 minus y1 over x2 minus x1. So that will be just v minus 0 over 15 minus 0. Huh? V minus 0 over 15 minus 0. Alright, so let's simplify the equation. So 14 minus v is still 14 minus v. 30 minus 15 will give you 15. V minus 0 will give you v, and then 15 minus 0 will be 15. Right, so from here, you can see that you have the same denominator, so we can just compare the numerator, which is 14 minus v equals to v. So 14 is equals to v plus v. So 2v is equals to 14. So we just, whatever we need to find, we have to put it at the left hand side. So just change the position. So 2v from the left, from the right to the left, and 14 from the left to the right. So therefore v is 14 divided by 2, that gives you 7. Right, so therefore the speed of the car when t is equals to 15 is 7 meter per second. Okay, so this is how you solved question 5, part 2. Alright, let's go at question 11. Again, it's another speed time graph. Okay, in this case here, we have an object that travels at the constant speed of 36 meter per second. Alright, so traveling at the constant speed of 36 meter per second for the first 6 seconds, and then after that slow down, so decelerate. Okay, this part here is deceleration. Right. Okay, so what do we need to find? It's this value here. Okay. Right, so we have to make use of this 12 meter per second squared. So basically that is your deceleration rate, and basically that is the gradient of this line, the gradient of this line here. So let's find the gradient of the line. The gradient of the line will be equals to 12 meter per second squared. Okay, so let's identify 2 points. Right, so the easiest point that we can use will be this particular point here, where your x coordinate is 6, y coordinate is 36. And then we can use another point here, where your x coordinate is t, y coordinate is 0. Okay, so the gradient of this line here that I've circled for you, how do you find the gradient? It's basically just y2 minus y1 over x2 minus x1, right? So you can just label this as x2, y2, x1, y1, right? So the gradient will be equals to 36 minus 0 over 6 minus t. And that gives you 36 over 6 minus t. So this value is equals to negative 12. Okay, it's not equals to 12 because we're talking about deceleration. Okay, deceleration. Right, so 36 over 6 minus t is equals to negative 12. Right, and so we can just multiply by 6 minus t on both sides. So that will give you 36 equals to negative 12 times 6 minus t. Again, I'm going to change the position now. Just put whatever you need to find on the left hand side. Alright, you can divide both sides by negative 12. So 36 divided by negative 12 will gives you negative 3. So negative t will be negative 3 minus 6. Negative t is equals to negative 9. So therefore t is equals to 9 seconds. Okay, so that's how we find the values of t. So important thing is that you have to let it equals to negative 12. Because we're talking about a negative gradient. It's a negative gradient, it's deceleration, so it's equals to negative 12. Alright, so how about part 2? So part 2, to find the average speed, then we have to find the total distance. Alright, the total distance. So basically the total distance traveled is just the area under your speed time graph. Okay, which comprises of a trapezium, right? Okay, so we need to find the area of the trapezium. So area under the speed time graph, which is basically the area of the trapezium. So the formula is half times sum of the parallel sides. So where are the parallel sides? Okay, I'm going to remove this. Otherwise it's very messy. Okay, so first one is this here, which is just 6. Okay, which is just 6. From here to here is 6. Plus here, this is the second parallel side. And since we've already found the values of t, you can just let t equals to 9. So basically the distance, the length of this line here, it's just 9 times your vertical height, which is 36. And that easily you can calculate it to be half times 15 times 36. That will be, I didn't bring my calculator, that will be half times 18. Okay, stop for a while. Okay, and that gives you 15 times 18, that will give you 270. Alright, so that will be the total distance traveled. So average speed will be total distance is 270. Total time taken is 9 seconds. So 270 divided by 9, that will give you 30 meters per second. Alright, so that's how you do question 11. Right, let's come to the last question. The last question again is also a speed time graph. Okay, so we have done enough questions to be able to just solve this quite easily. So if you look at the first part of the questions, you're asked to find the acceleration of the train during the first 20 seconds. So basically what we are finding is the gradient of this line, because the acceleration is equal to change in the speed over change in time, right? So basically it's just the gradient of the line. So acceleration is equals to change in speed over change in time. Alright, change in speed will be rise, which is just 30 minus 0. Change in time will be your run, which is 20 minus 0. So 30 divided by 20, that gives you 1.5. 1.5 meter per second squared. Okay, so this is the first part of the answer. Right. Second part of the questions require you to find the time taken for the whole journey. Okay, that means if I'm going to let the time taken for the whole journey to be t seconds, that means it takes t seconds for the train to complete the journey. So this is what we need to find. We need to find this value. Right, but you're given that the train decelerates at the rate of 0.75 meter per second squared. So which is the part that give you the deceleration? The part that give you the deceleration is this portion here. This is the part that the train is decelerating. Okay, so same thing, let's identify 2 points. So the first point I can use will be this point here, where the x coordinate is 60, y coordinate is 30, and then the second point here, x coordinate is t, y coordinate is 0. Okay, so the gradient of that line, the highlighted in blue, will give you your deceleration. So the gradient will be just y2. You can just label it as x1, y1, x2, y2. Okay, or label it as x2, y2, and it's easier that way lah. Alright, so that will give you 30 minus 0 over 60 minus t. And this is equals to negative, remember? Okay, as what we have done earlier on, is negative 0.75 because we're talking about deceleration. Alright, so 30 minus 0 is just 30 over 60 minus t. So we're just going to multiply both sides by 60 minus t. Alright, so this will just, this and this cancel off, will just give you 30. And this one you can just use your calculator to work out the value. It's negative 45. And this time this will be positive 0.75 t. Right, so that's right now. Whatever we need to find, just put it on the left hand side. It's easier for calculation. So negative, so 0.75 t will just be 30 minus, sorry, 30 plus 45. So that will give you 75. Let's continue here. So therefore t will just be 75 divided by 0.75. 75 divided by 0.75, that gives you 100. So therefore the total time taken will be 100 seconds. Okay, total time taken for the whole journey will be 100 seconds. Alright, so this complete assignment 5.3. Okay, it's not difficult, so please put in effort in doing it.